Hi all, welcome to the new video. So in today's video, we'll be discussing some questions from the topic arc welding. So we already created one video of arc welding, which is an additional video which will cover 15 more questions in connection with the arc welding. So here is our first question. Amount of time during which transformer will be used for welding normal load condition is known as. So amount of time during which the transformer will be used for the welding under normal loading condition. The amount of time during which the transformer will be used is called as duty cycle of the transformer. It's called as a duty cycle of the transformer. Second question, amount of voltage required to generate the arc under no load condition is known as. Amount of voltage required to generate the arc under no load condition. So the amount of current required to generate arc under no load condition is known as short circuit current, SCC, short circuit current. Okay. And the amount of voltage is known as short circuit voltage. The amount of current required is known as short circuit current. Amount of voltage known as short circuit voltage. The amount of current required to generate the arc under no load condition is known as short circuit current. We have already discussed short circuit current. If the open circuit voltage is 60 volts and the short circuit current is 20 ampere, then determine the voltage required for welding if the current required during the welding is 10 ampere. It's a simple problem in which voltage is given by OCB minus I divided by SCC into OCB. That is, OCB means open circuit voltage, which is given as 60 minus I. It is a current. Current is given as 10 divided by short circuit current, that is given as 20 ampere. 20 into open circuit voltage, OCB, it is 60. So the answer will be 60 minus, get cancelled. So it will be 60 minus 30, the answer is equal to 30 watts. So we can expect these kind of simple questions for the examination. How does the arc voltage depends upon the length of arc L? Arc voltage can be a function of length, arc length. So we can represent voltage is equal to A plus BL, where V is the arc voltage and L is the arc length in centimeter, where A and B are called the constant. So V is a function of L. V is a function of L. There is no inverse, there is no square, there is no root. So V is a direct function of L, arc length, which does not a function of flux in submerged arc welding, which is not a function of flux in submerged arc welding. Options: completely cover the weld zone to prevent the oxidation of the joint, to prevent the spattering of the molten metal, to prevent the sticking of molten metal. Actually, the first three are the function of flux in a submerged arc welding. So the fourth one is the correct answer, which is not a function of submerged arc welding. In which of the following gas welding process a non-consumable electrode is used? In which of the following gas welding process a non-consumable electrode is used? Anyway, all the gas welding, normal gas welding, normally all the gas welding process is using consumable electrode. Here they have mentioned about arc welding, which is used gas welding. Okay. In tungsten inert gas welding, that is again it's a tungsten inert gas welding. We all know that's a TIG welding, which is not using a consumable electrode. So tungsten inert gas welding is the correct answer. What is the only difference between plasma arc welding and TIG welding? What is the only difference between plasma arc welding and TIG welding? The construction torque is the only difference between the plasma arc welding and TIG welding. Both TIG welding and plasma arc welding using the tungsten electrode. The flux is not used, gas is not used. It is, both are using gas. Tungsten electrode is not used. So we can remove all this. Construction torque is different for plasma arc welding and TIG welding. Plasma arc welding, the gas is, in plasma arc welding, the gas is, we are using ionized gas in plasma arc welding. In plasma arc welding, the gas is ionized, electrode use is made up of tungsten, and the filler metal is also used in addition to that. So this all in connection with the TIG welding. We can compare the plasma arc and the TIG welding process. If the heat transfer efficiency is 0.5 and the melting efficiency is 0.6, then the overall efficiency. The overall efficiency is given by is the product of efficiency melting into efficiency heat transfer. So we can multiply these two values 0.6 and 0.5. 0.6 into 0.5. Answer is 0.3 will be the answer. So answer is option C, 0.3 is the correct answer. The deflection of arc in arc blow is by. The deflection of arc in arc blow is by. Actually, the deflection of arc is done by the magnetic field. They have given the option electric field, not my answer. Sometimes we will go for electric and magnetic field. The magnetic field is the only reason for the deflection of arc. Hydrostatic field never comes in welding. The total efficiency is 0.35. What is the welding speed in mm per second if the cross-section area is 5 mm square and the welding power is 2 kilowatt? The heat required for the welding 100 joule per millimeter cube. Again, it is a very small question. So we can write N is equal to P into efficiency total divided by Q into A. Okay, where P is the power, efficiency total is equal to 0.35, Q is the heat, and the area is equal to 5 meters square. So it will be 2 into 10 raised to 3 into 0.35 divided by Q, 100 into 5. So you will get the answer as 1.4 will be your answer. So the total answer obtained is 1.4. Which of the following gas welding process uses constant voltage? Which of the following gas welding process uses constant welding? In gas metal arc welding, we will be using the constant voltage. In gas metal arc welding, we will be using the constant voltage. Which of the following inert gas used with the DC power supply only? So we have familiar inert gases argon, helium, CO2 and nitrogen, and in this one inert gas is used only with the DC power supply. So the answer is CO2. The CO2 will be used with the DC power supply. In order to prevent oxidation and retain the molten metal in stud welding, which of the following is used? Ceramic rings, metal rings, non-metal rings, flux. The answer is ceramic rings. In order to prevent oxidation and retain molten metal in stud welding, ceramic rings are used. That's all for today. So we'll be back with another video. And we have to add one more point. CO2 is used only in DC power supply. It cannot be used in AC power supply. Argon and helium can be used in the AC power supply. Okay. So thank you for watching. We'll be back with another video.